Hi, I'm Chen Junwei. Today, let me show you binomial expansions. Firstly, I want to ask you a question. Do you know how to get the expansion of x plus y n power? Today, let me bring you to solve this problem. In order to solve this problem, we can explore easier problem firstly. We can let n be 1 firstly. Then we get x plus y first power. It is equal to x add y. What if let n be 2? Then we get x plus y squared. It is equal to x plus y times x plus y. From distributive law of multiplication, it is equal to x times x plus x times y plus y times x plus y times y. So we get x squared plus y squared plus 2xy. According to before, we can regard x plus y squared as x plus y times x plus y. Select one term to multiply in each bracket. Then we get 4 possibilities: x times x, x times y, y times x, y times y. However, it is randomly instead of in order. So, we know that we must choose a term to multiply in each bracket. In fact, every term must be a pair, so it is equal to we choose them randomly. Let's understand it more easily by exploring x plus y squared. Example: x plus y squared is equal to x plus y times x plus y. So the possibilities of choose x and y are equal. Have you thinking how can we express its possibilities? Firstly, we need to find out how the difference appear. Can we make out the problem? In fact, the process of choose only has 3 possibilities. Choose 2x, choose 1x, 1y, choose 0x, 2y. So, only can we express the difference of number x and y can we succeed to express its possibilities. Therefore, we can use this sign, this mark, to express them. It is called n choose k. It means the number of situations of we choose k from n. It is equal to n factorial over k factorial times n minus k factorial. Now we can express it. Is equal to we can firstly choose 2x 0y, then it is equal to 2 choose 2 x squared times y 0 squared 0 power. Then we plus 2 choose 1 times x times y plus we choose 0x, it is equal to 2 choose 0 times x 0 power times y squared. Now we have expressed the all of possibilities. This is its expansion. In order to make the formula more regular, we write in a special order. Discovered. The first term is 2 choose 0. It means we choose 0x, 2y. Then is 2 choose 1, 1x, 1y. Choose 2, choose 2, 2x, 0y. So, the special order is we can choose x to represent 2 choose k. To represent we choose x, kx, then 2 minus ky. So, the rule is choose 0x, choose 1x, choose 2x, choose nx. We have learned how to get the expansion of x plus y squared. What about x plus y cubed? It is equal to before. It is equal to x plus y times x plus y times x plus y. Likely we choose x and y randomly, then list is all possibilities. 3x0y, 2x1y, 1x2y, 0x3y. Then we write them in order. So then we get its expansion. We have now its principle. Let's try the first question, which is x plus y n power. It is equal to x plus y times x plus y times x y y times x plus y n times. It is equal to choose x and y from n times x plus y. Firstly, we can choose 0x and y is equal to n choose 0 times x 0 power times y n power. Then we choose 1x n minus y minus 1y. It is equal to n choose 1 times x times y n minus 1 power. What about we choose 2, 3, 4, 5, 6, we choose k. K can represent any number, which k is a positive integer and k is small or equal than n. Now it is equal to n choose k times x k power times y n minus k power. Then we choose k plus 1, k plus 2, k plus 3, blah blah blah. And the last term is choose nx0y. It is equal to n choose n times x n squared times y 0 squared. This is infinitely situations which can't be listed completely. From situation of choosing a kx, we can give a conclusion. How can we find a formula to express its expansion? The final, we need to plus them, all of them. So maybe we can use sum of some function. We can use this function, means sum of. So the first term is k equal to 0. So k is equal to 0 from 0 to n. The last term is n. Then k can represent any number 0, 1, 2, 3, 4, 5, blah, 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 and n to n. So like this term, the any term is n choose k times x k power times y n minus k power. So we have expressed its formula. Yes, like this. We call this formula bionomial expansion. It is what to say is that n choose k represents the coefficient of each item. Then the second question is, what is the situation which its coefficient is largest? How to make about this problem? Thinking, if a coefficient of an item is bigger than its next coefficient and the before coefficient, we can say the coefficient is the local largest. Yes, like this. The same as function. Have 3 local largest value, and we can compare the 3 of them. So find the largest one. It is the largest coefficient. So suppose like this, and then we can have 2 formula. Calculate them. We get the range of k. Here is the range of k. Now, don't forget n is positive integer. So, if n is odd, we get the range of n is like this. Then we can get only 1k. It's n over 2. But if n is even, we can get 2k. The first is one of is k is n minus 1 over 2, the other is n plus 1 over 2. So now we need to compare them. When k is n minus 1 over 2, we get this formula. When k is, sorry, here is the fault. When k is n plus 1 over 2, we get this formula. We discover that they are equal. Wow. So we get the conclusion. If n is odd, we get only 1k is n over 2. If n is even, we get 2k is n minus 1 over 2 and n plus 1 over 2. They are equal. So it has two coefficients, largest coefficients in terms. Pay attention to the largest term. We can discover that they are the middle term of a polynomial. So we write every row, when n is equal to 0 to 1 to 3 to 4 to n, they are coefficients. We can get this picture. It is means Yang-Hui triangle. 1015 years before, Jia Xian, a mathematician in Song Dynasty China, proposed Yang-Hui triangle firstly, which is used to solve high-order square root calculation. The every row of Yang-Hui triangles is equal to coefficients of x plus y n power. So in other words, we can write some row without picture. Now, we have learned x plus y n power. N is positive integer. What about n is not positive integer? It is a very complex problem. However, we can learn a formula to help us to calculate 1 plus x n power. It's this formula. If we need to use it, x must be satisfied that minus 1 is small or equal to x. X is small or equal to 1. Now, let me have a summary. Today, we learned how to get the expansion of x plus y n power. Having learned about Bionomial expansion, having known that how to get the largest coefficients, having known that the relevance of Yang-Hui triangles and binomial expansion, having known the formula of x plus x, 1 plus x n power. So, today we have learned many knowledges. The ending. Thank you for your listening.